Good morning, Mr. Friedrichs. Good morning. Howdy. Crowd's a little thin so far this morning. I only see 3 of you here for right now. We'll see. Morning. All right, got some coming in just in the nick of time. All right, let's go ahead and get started. Today I don't have any PowerPoint slides because what I wanted to do was to go through the homework assignment as I solved it, and to give you guys an idea of one of the ways that you can break down a problem to create a solution. So we're going to be going through this in detail. And basically how to kind of think about a problem. So let's take a quick look at what the assignment was. So it's important to look at the objectives because those will give you the clues of things that you might have to do that are different than what you've done in the past. So what have I done? I've asked you, I want to demonstrate the ability to use the graphics library. It's a handy tool to have when you've got one of these edgy boards. Demonstrate that you know how to use a semaphore. And I want to demonstrate that you know how to deal with the mutex. So what we're going to do is we're going to create a program that's going to display the program name and version number on the display. It's going to write a line on the display that will have the raw A to D count from the joystick. We're going to have another line that is going to display the raw A and D count at the moment that somebody presses the joystick with the S2 button, and yet another one for the S1 button. The things that I've asked you to do to demonstrate here is that you need one task that's going to update the second line of the display once a second. So that's just the constant joystick ticking. You're going to need another one that is going to update the another line of the display when the S1 button is pressed. Yet another line when the S2 is pressed. And I want you to use a semaphore to indicate that there's been an interrupt to display the third or the fourth tasks. So, where to start? Well, the first thing to start is that you haven't in any of your assignments yet messed with the A to D converter, in particular with the joystick. So where I would start, where I did start on this, is that I went over to the example that I downloaded from the Resource Explorer of the joystick and took a look at what they had done. So let's take a look at that together. Okay, so there's all the rigmarole. I don't see any comments in here that really tell you what the heck it's doing. Now in this case, they're displaying a raw 14-bit ADC values off of the XY. So let's take a look at what they've done here. So they're turning off the watchdog timer. And they come in here, they're setting up all the core voltage and stuff, initializing the display, setting the orientation of the display, getting the display initialized. So the context is the first thing that you have to do to get the display working. They're going to set up to have a foreground color of red and a background color of white. So they're going to print white text on or red text on a white background. They're using the fixed 6x8 bit font. They're going to display, and they're going to write centered on the display the word joystick. And then this is something that we need to make note of. So they are configuring the ADC input pins. Well, that's an interesting sound over on Mr. Cronk's phone. Let's get everybody muted here. Okay. So this is the first truly interesting thing that I've seen, and this is identifying which pins are associated with the A to D converter. And so we've got port 6, pin 0, port 4, pin 4. We're going to want to know that a little bit later on. Now, there's another way that we could have found out where that was, and that is if we go over here to the data sheet, or the user guide actually, for the Boost XL. And we go down here and we look at the joystick. Take a look at what it says down there, joystick. It's on J1.2, J3.26. And if we go back to the schematic down here, see here, joystick temperature, ambient, analog, accelerometer, joystick. Okay, so here's the joystick. And it goes to joy Y, joy X. We don't really care about joy cell. That's the button. And if we go find the I/O pins up here, we see that joy X is on J1 pin 2, and we see that joy 1, joy Y is joy select, joy Y right there is on J3 pin 26. Huh. So if we go back here, say 1.2 and 3.6, well, that's not what that says. Those are port numbers. How do we go to that map? So the answer is, but it does correspond with what the comments said. So let's go back and let's take a look over here and see where those puppies show up over on this guy. And it turns out that they have a really interesting naming convention, I think. Let's get down to the schematic. Okay. So look at the way they've named these ports. I'm just going to pick one here. Look at the way they've named this port. They've named this signal P4.1 IO J1 underscore 5. Interesting. So it's got the port number, and it also has the function that's available. So this is just digital I/O, and it has the J number. So let's go down. Let's see what our connector looks like at the pins we were talking about. So we were talking about, remind ourselves which pins we're talking about. We're looking at J1.2. So let's look over here for J1.2. So J1, pin 2, that is A15, J1.2, port 6.0. Oh, golly, that corresponds with 6.0. So that's where we get that. And if we look for the other one, which is going to appear on pin 4.4. Look at 4.4. There's 4. Pin. That doesn't look right. Let's go back and look again here. Pin 4 on port 4. Right. Pin 4 on port 4 is the J326. So look here, J3 pin 26 is right here, which is port 4.4. And interestingly, it's A9. That's analog input 9. The other one that we were looking at over here is analog input 15. Where did we see that? 15. J6. J1 pin 2. J1 pin 2. Right there, A15. So A15 and all that. So let's go back and take a look at what all they've done. So here's what they've done. They've configured these pins. They've enabled the module, and what they're doing is they're setting this thing up to do, oh, this is important because we'll want this for setup. They're using the 2.5 volt reference in here. And they, in fact, are actually setting up automatic conversions that are interrupt driven. Now, we could certainly do that. And if you take a look at what they're doing, the way they're doing this is they've got an interrupt handler that's reading those values and printing them every time the interrupt handler goes off. Again, nothing wrong with doing it that way. We weren't told to do the A to D conversions on interrupts. And it turns out that if we choose to use the A to D conversion utilities that are part of the, can we zoom more? Thank you. I'm sorry. I apologize for that. Let's see what we can do to get this thing zoomed up here. I can go in and set up my preferences, Code Composer Studio. Trying to remember where we set up the editor. No. Appearance. Nope. That's a great question. Hang on just one second. Work with me, guys. We'll get the, we'll try to get this thing zoomed in a bit. Yes. Preferences. There we go. got to be under general. There we go. Appearance. Colors and fonts. Okay. Let's get this guy. Edit his font. Let's go to 14. Is that better? Yeah, it did make that a little bit bigger. Okay. Okay, I get that was mostly for the diagrams and stuff. So I think we're kind of through with the diagrams for the time being, but I will make sure we zoom better when we get into those. Okay. So we're using a slightly larger font so we can see what's going on. And you can see what's going on here, that they're basically using those two ports. So how the heck are we going to deal with that? And I'm going to go ahead and close this. We don't need this anymore. How do you deal with that in the with the RTOS? And one of the things we talked about, we did this with the buttons, is we have these two files, this MSP EXP432 P401R.C, this guy right here, and his friend and companion, this guy. And if you recall, we made some changes in there to be able to use the access the LEDs. So let's go in and take a look at what all we need to change. So in the original of this was set up for A to D port 0, analog input 0 and analog input 1. So we're changing that to talk to analog 15 and analog 9, which are the two ports that we were talking about. And in here, to set up this table, we have to tell it what channel it is. That's a constant. We did not define that constant. That's actually defined elsewhere in the TI stuff. We tell it that we're on port 6, pin 0, port 6 for A15. And we want to use the tertiary function for that pin. So we have to set the mode. It's A to D conversion, so that's the tertiary function of the pin. And we need to set the reference voltage. Remember, we looked at that earlier, and we set the reference voltage to 2.5. I went ahead and started with an 8-bit A to D. We could certainly, on this particular part, go up to a 14-bit A to D. I chose the 8-bit just because it ought to be enough for a joystick. And so we did that for both of these. And over here, we had to change these that were ADC 0 and ADC 1 to be ADC 15 and ADC 9. And notice it didn't make any difference what order these were in. What is important is that the order match here and here. So that gets our A to D inputs in. The other thing that we have to deal with are the buttons. So let's go down and take a look at what we did in GPIO. And notice how they've done a relatively nice job of labeling these sections. So there's the A to D converter. It's DMA, which we're not going to be using for right now. That's the power initialization. GPIOs, aha. All right, so we need S1 and S2 on the EduKit, and I've already put those in. You can see I went to the data sheets and I found that button 1 is at J4.33, button 2 is at J4.32. Okay, so those are input pins, and I've configured them as interrupts that hit on a falling edge. I over here, make this same entry, over here for button 1 and button 2, make sure that that's all in the same order as, oops, didn't mean to do that. here? Okay. They have to be in the same order. So S1, S2, button 1, button 2 on the edge of your board. S1, S2, button 1, button 2. And then all of our LED stuff, which we're not in this case using, but we are using.
I think there's a full page. Oh.
Hello. I will mute you just for grins. Welcome. Okay, so we see how that's all set up. So now we've got all of our I/O set up. The one thing that we do have to do is that now that we're using the ADC, in your example code that I gave you, it didn't have the ADC initialized. So we do have to call the board INET ADC. So let's start talking about how we're going to structure this. So you guys know that I like to use multiple files to set logical functions apart. So I'm going to start off, because they're probably the most straightforward functions, I'm going to start off with the analog stuff. So I'm going to start off and take a look at what I did for the joysticks. So I'm going to go over here to my header file. So I've got 3 functions that I am initializing, that I'm going to be using to play with the joystick values. I have a function I'm calling initialize joystick, having a function I'm calling joystick X, and one that's called joystick Y. I hope that's moderately obvious what they're doing. But we're setting up to talk to the, one of the things we're doing here is that we're setting up to talk to the A to D port using the TI kernel, and the catch here is that it's it's a separate library, and we haven't used this library to talk to the A to D port. So we need to figure out how to do that. And as it turns out, I've already gone in here to the Resource Explorer and found the appropriate API calls. And it's under the TI RTOS drivers. So if we go to the TI RTOS drivers, let's go to the main page. So these are the TI RTOS drivers. So if you want to know how to interface into any of these things in the TI RTOS, we're more concerned, obviously, with the 432 than we are with the 430. But these are the general interfaces. These are the specific for particular parts, the 430 versus the 432. So I'm going to flip to GPIO first because that's one that you're already familiar with. Okay, and this is the documentation. So it shows you all of these different calls, and you can link to them. And in this case, these are macros. These are all implemented as macros. But then you have all the functions, interrupt, enable, callbacks, those sorts of things. It's kind of cool that that's all there, but let's go back to the main page and let's look at the A to D converter. So, very conveniently, they have an example up at the beginning of how to do this. Now, I spent some time looking. They don't have, as part of their driver package, they don't have anything that is interrupt driven, which is fine. By default, with this particular library, we'd have to go back to the MSP 430 where library if we wanted to do the interrupt driven stuff. But we don't need that, not for this time around. We're not doing anything super demanding. So let's take a look at what we're going to do. So the first thing they show you is how you open up the driver. So you've got these 2 variables here. And boy, I'm really surprised with this library, but they have a param structure that we have to initialize with a params INET function. Amazing. And I'm not real sure why that's required, because at the end of the day, it is exactly the same as This structure doesn't have anything useful in it. I don't know why they do it, but you got to do it anyway. But we do an open, and it gives us a handle that we can now refer to the A to D channel with, and we pass it that parameter structure, and we also pass it a variable that indicates what the particular port is that we want to be talking to. And then when we're done using it, we can close the A to D port. We're not going to close ever. Then they have this chunk of code that shows how to use the converter. Turns out there's actually a mistake in this documentation, because they show this value right here passing to A to D converter. They show it here as taking a FAST16 uint, which is not always compatible with the uint16. And as it turns out, it's really looking for an unsigned int here. Let's see what the documentation says. And actually, the documentation says that it's expecting a uint16. So if you were to, let's go back here. If you were to actually declare your A to C value like this, you would get a warning. And in fact, it would behave very badly, because as it turns out, FAST16 is really a 32-bit value, so you're pointing to the wrong size value over here. So it's very important to heed that particular warning carefully. All right, so let's go back to what we've done. We can see what it wants to initialize. We need to see what it needs to do to write. So now let's go in and take a look at our joystick function. And let's see how I did this. So we need to include the driver header file, the adc.h. We need to include the board header file, which will ultimately end up including this .h as part of that. And then we need to include this joystick.h that I created over here that has my external functions defined. Now, I have defined in here as static variables, so that nobody but this function can see them, the handles for the X and the Y analog port, and this ADC params structure for initializing. Now, actually, that could have been a local here in my initialize joystick function. I just chose to make it global. In fact, just for grants, it's a better place to put it. We're going to be recompiling here shortly. So give me some place to make a mistake that we have to correct. Okay, since that only has to exist, this variable only has to exist while we're doing these opens, let's go ahead and put it here. That way we're not taking up room on the stack if it's not needed. So initialize joystick, we're just opening up the two analog ports, putting in these global static variables. And then these are my functions to read the A to D converter. So I'm going to get, need a local variable to put the A to D conversion in. So I have my value, put it there, and voila, we're off to the races. By the way, if any of you have weird problems, one of the things that I did not do here that I should have done here, in fact, let's go ahead and do this. If for some reason this ADC does not open, and when I did the, first time that I did these, I had left in the old definitions that were using different different reference voltages. And when it initialized everything, it apparently did not properly initialize the A to D converter as part of the board setup. So the first time that I called these things, the open worked fine, but as soon as we did an A to D convert, the open worked, it didn't crash, but it returned a null variable here. and that caused this, when we had this particular thing going, to crash. So what I'm going to do here is that I'm going to say, you know what? I don't want this to crash ever. I'm going to do if x analog equals 0, then I'm going to return 0. And then I'm going to do the same chunk of code here. Except that's Y analog. Okay, so now we've got more robust code that is going to still work and compile fine. In fact, let's go ahead and do it. Whenever you're making changes, it's always a good idea to do a recompile just in case. Huh, so it was my console that I changed the font on. Didn't think that other one looked bigger. Everybody can still see, I assume. Everybody can see what we're looking at here. So we're going to call these joystick values. They're going to convert. They're going to return the value. Everything's going to be fine, and we're doing some error checking here. So the consequence of not doing the error checking is that you go off to the exit function when that's equal to a null, and you're screwed. In fact, I will show you what happens here. So let's do a Y analog equals 0. We'll just lie, and let's compile and run my little joystick program and see what happens. All right. So we're going to tell it to run, and it has, let's see what's happening here. It won't crash because I have my error checking in there, remember? So I didn't. So let's take the error checking out. Wonder why it didn't crash. Okay, so that's the Y analog. So we're going to do. Okay. If you learn nothing else from me, you will learn that if zeros are vastly superior for commenting out code that you want to take out temporarily. So let's do this. All right, we're going to tell it to run. Takes just a second for the display to go. And oh my God, we are now in loader exit. How on earth did we get there? So there's not a whole lot that you can do to debug at this point. We can, see how there is. So, view, I believe that we can look at the stack. That's just how much stack is used. Okay, well, let's look at the console. Console may have some clues. It doesn't. It just shows that these are some of the Cortex variables, and it says that we're basically screwed. So the only way you're going to find this bug, the best way to find this bug, is set breakpoints and figure out where it's occurring. But what you do know is that if we hit this load or exit, that means that the C program has quit. It's probably, in this case, due somewhere in the, to an assertion somewhere in their library code. Obviously bad. If this were happening in a real-time system, you'd be totally screwed. So let's go back and we'll fix our little problem that we created. So let's go back over to joystick. So one of the things that I can do, by the way, is that I can do that, and now this is back in the code. We're not going to do that. We're going to go ahead and take this out because we don't need it. And we're going to take that out. And we're going to save this. So you see what I'm doing to do the joystick. There's nothing magic here. It's pretty straightforward. Again, if you break things down a piece at a time, it's pretty easy to do. So we just need to make sure that we initialize the joystick before we use them. And we have these two joystick functions that read values. So the next thing that we need to do is we need to deal with the buttons. So let's go over here and talk about the buttons. Button, who's got the button? So I've chosen, you could have chosen, there's no reason that you could not have used two different tasks, but I said one, you need to have a task for button 1 and button 2, and what I'm choosing to do is I'm choosing to do one task that has both buttons, and what the task is going to do is that it's going to pend until it sees a semaphore get posted, and then it's going to share the joystick. I thought that was a very clever name for the function that displays the joystick information. And I'll show you what that is here in a couple of minutes. That's not part of the assignment. That is a Professor Willie enhancement to the assignment. Okay, so button task is pretty simple, but what I've set this up for, so the first argument is going to be, for the button task, is going to be the semaphore handle. So we know what's, there we go, you see it's the semaphore handle right there. And I'm also going to pass it the line number of which we're going to share the button information. So that's that task. So let's talk a little bit about what's going to happen here. So we have to have, we have to also have an interrupt so that we can post those, that semaphore. And so I've written two little functions here that are interrupt functions, one for button 1 and one for button 2. Now, as it turns out, since we're using this GPIO callback, it turns out that when we set this as a callback function, when the interrupt occurs, it actually passes the identifier for the for whatever that input was that generated the interrupt into the function. So we could have had just one callback routine that was called by for both buttons, and then read this index to see if it was button 1 or button 2. So at any rate, we are, in this case, I've got this button inet. I'm passing it a couple of handles that I'm storing into a local variable. And in fact, because, so I did this a little bit differently from a structure standpoint. And I've got the handles for the semaphores, S1 handle, S2 handle. Those are now global to here. So I shouldn't have to pass them in here. I don't need this. And except we need now to have up here, those are, I don't need these guys that I just deleted, and I'm going to use those directly down here, which means my button INET doesn't need any parameters anymore. Simplifies that. All right, so let's talk about how this all works. So before I initialize my button, so let's talk about how this is going to go and kind of order that things need to happen in. So button INET is basically going to set up the callbacks so that when you press the buttons, these functions get called. The catch here is that these guys are posting to a semaphore. If that semaphore isn't, if the button hits, that semaphore isn't ready, then you're going to go off and exit again because bad things are going to happen. Not all the structures are set up. So the first thing that we have to do is to set up the button semaphores. And I'm going to change, I'm going to add a comment here. Okay. So we need to set up the semaphores, and you guys know how to do this, I think. But if you aren't sure, then you can go over here to the TI API stuff. I happen to have already called this up. Go into sysbios, go into the kernel, look at semaphores, and there are all the semaphore calls. Or you could pull up my old lecture notes about how to set up a semaphore. But what we're going to do is that we're going to set up a semaphore. We're going to use a binary semaphore, and we're going to set it up to be priority based because that's what we do in this class. And then we're going to construct two semaphores, semaphore 1 and semaphore 2. Okay, now I'm looking over here at the group chat. I'm going to ask you guys questions, see if anybody knows the answer to this question. If we take a look at the, let's hover over this for a second. So the first parameter is the structure. The second parameter is the count. That's the initial value that we set the semaphore to. And then we have the pointer to the parameter structure. Why does can anybody venture a guess as to why we set that to a 0 in this case? No, did I do that? Let's go down here. I did. Thank you. All right. So let's ask again. Does anybody want to tell me why we would have set this to a 0? All right, I'm going to ask it a different way. Why would, well, what is, if we do a post, what is it going to set the value of the semaphore to, a 1 or a 0? That's right, it's a 1. Okay, so if we set it to a 1, that means that when we initially construct it, the semaphore will assume that it's already been set. So when we pinned, we'll actually act as if somebody had pressed the button. By setting it to 0, that says this semaphore hasn't gone off yet, it's not available yet, and so anybody pinning on it is going to wait until one of the button functions does a post. So we create the two semaphores, we get their handles, put those in a nice common place, and now we can call button INET. Now, even though our tasks aren't running, it's not going to hurt if this interrupt function gets, if these interrupt functions get called, they're going to post to a semaphore. Yeah, the semaphore hasn't been hit yet, but that's okay. Or, I mean, the task that's going to monitor this is not going to be running yet, but that's okay. And so we set the callback functions, enable the interrupts, and we're off to the races in button init. Now we're going to create the task threads. Now, as you can see down here, I've got this share the joy function, which is actually going to write to the display. Because of that, we need the larger stack size. So you'll notice that I've got my button stack size set to 2048. So I'm going to create my stack, stacks. You'll notice that S1 is being passed the S1 handle, and S2 is being passed the S2 handle. We have 3 and 4 for the lines on the display for them to go to. And I've got a task for stack 1, a stack for task 2, and then we're using the button task for both of them. So they have separate tasks. They have separate task structures, separate stacks, task structures. And when we construct them, we're going to have 2 versions of this button stack running. One is with the first semaphore and this argument 3, one's with this semaphore and the argument 2. So now we've done everything that we can do on buttons. Let's make sure that we haven't done anything to keep it from compiling. That's, whoa, target not remade because of errors. We got here 967. Ah! And that, look at that. Forgot to change that there when we were improving. Much better. Okay. So now we have the button function. So by the way, the only thing that we need to do is start button task, right? Because start button tasks is this guy right here. And he initializes the interrupts, gets those buttons going. So let's go back over to our main graphics function. Oh, let me show you in here. Notice I've declared the joy as having, I've declared the joy. I've declared share the joy so that you can see what that's doing, okay? We're passing it a label and a pixel count. Let's go look at share the joy since we've been talking about it. Here's what share the joy does. It takes this label right here, which is just a character string, and it takes the joystick X and joystick Y value, and it puts them into a buffer. I've made a little 20-character buffer here, and it prints it in. So if you passed it BTN here as the string, it would be BTN colon and then 2 values. I did the %5 so that they always show up in the same place. Great, important embedded hint here. Notice this is not sprintf, this is snprintf. The N is important. When you're doing embedded programming, it is really important when you're using the string functions to always use the versions of the string functions that have an N inserted in them. This is because these all take the size of the destination string into account. So you'll notice that I have here, this second argument, the size of display buffer. What this does is that if something went wrong, so let's say the joystick returned a value that didn't go as 5 digits, but went as 15 digits because it was a 32-bit number, or 12 digits because it was a 32-bit number. We could try to do an sprintf of something that was much longer than 19 characters, 20 with the null, but it could be much longer, and then you've messed up, right? Now you're out writing in memory that you don't know what's going on. snprintf prevents that from happening. It will only write as many characters as there are room for in the buffer. So anyway, so we create this string that we're going to display. The next thing, and you'll see these locks were already created as part of the initial graphics program. But one of the things that we want to do is that we want to make sure that we lock the graphics display before we display to it. And the reason is that if we were in the middle of doing a write to the display, when the interrupt happened, somebody pressed the button, we got ready to draw that string on there, it could in fact garble the information on the display. So we have to make sure that any time that we're drawing to the graphics display, that we actually use a mutex to lock around it. And I have done an indentation convention that I think makes life easier to deal with on the mutexes, and that is that when I lock a mutex, I indent everything below that until I actually unlock the mutex. So in this case, we're just drawing the string. We're going to draw it over at the far right-hand side on the particular row. I've defined that macro to compute a row for me, and we're going to overwrite the text. If you use transparent text, it doesn't rewrite the background, and so it will leave it'll leave any of the dark bits from the previous character on the display. So you need to use the opaque text in here with the graphics stuff. So that's share the joy. So we know that share the joy is called by the button task whenever we get the semaphore posted that says somebody press the button. All right, so now we know what share the joy is doing. Let's go back and let's take a look at our main graphics stuff. So lots of includes here. Display stack size is 2048. I'm not using this. I'm pretty sure I'm not using this. Oh, I am. That's my sleep timer. Okay. It's a bad name. That's left over from the original. So let's do, let's say this is toggle. Let's see how we're going to do this. This is display update. Will be 1 hertz. Okay. And that actually, I thought that seemed a little fast. Okay, I'm going to do that. And we're going to call this update display. All right. Graphics context, that's just required to use the graphics display. This is our gate mutex that we're using. This is our main display task. And so we have the function that starts the display task. Again, this came out of your example code, but it has to create the mutex. It's going to be used to protect the gate, or protect the display. And then we construct the task, and now the task is running, and this is our display task. So remember, with the TIR toss, you have to have a lock handle whenever you're doing an enter and a leave for the mutex. So we have to declare that variable. We initialize the display, set the orientation, set the fonts. And then this is my pretty little maroon box. So I will, just a second. Let me turn on the video here for a moment. And hello, okay. And then I am going to Well, not sure if you guys can see that. I'm going to stop the share here so that goes full screen. Now I can focus it at least. All right. So let's see if we get this thing where it'll focus in. Kind of hard to get a good focus on this at a zoom level that you can see everything at. But this is the name, and then you can see over here that is the version number. Okay, so let us pop back to screen sharing. Wanted you guys to be able to see what that was like, that little maroon thing. So I have this maroon box that I'm putting up here. So I draw the maroon box, then I write my title. And notice that I have display 1. I'm going to change that to 2 because we've made changes here in class, and we want to be able to identify which version of the program it is. That was part of what we intended to do. And so you can see in this case, I'm using a different font. I defined this title font probably over in here. Yeah, so this is a different font than I'm using for displaying everything else. There we go. So we set the font, we write the stuff on the display. We're writing this in white because it's on that maroon background. Then we come down here and we reset the colors back to printing black characters on a white background. And then I use my data font, which is the fixed character font. And then I free up the handle. And notice that I'm doing things in chunks, locking the display in chunks with the mutex. It's good to do this in appropriate moderate-sized chunks when you are using a mutex to lock things out. That way, if an interrupt happens, something more that's a higher priority to get displayed could potentially get displayed between drawing the background, which takes a little while, and drawing these characters. So then I'm initializing my joystick. Okay, remember that? That just basically is opening the A to D values. Start my button task, which we just went over. And this was that section here where we were going to, in the main task, after we've initialized all the graphics, start all the tasks. And this main function, he's going to do my the function that we had. Let's see here. Right here, we're going to display a lot. We're going to display the XY once a second. So this is the guy who does that. So he's going to sleep for the update time. And then he's going to, I'm going to put this prefix timer on him. He's going to display every now and then. So main program, you initialize it, you start the display, you write it, you do a BIOS start, everything is running. That is my solution, and I will, let's go ahead and get this going, and I will show you that it does in fact work. Actually, it did in fact work past tense. We've made alterations during this lecture, so it's possible that I screwed up. Okay, so it is now running. Let me stop it, and I'm going to move this off to the side. I'm going to stop sharing my screen. Stop sharing the screen. We're going to run the video. Okay, so let's start the program. I will tell you when I press the start button. So I am hitting the debug button. Well, it was focused. Ah, there we got it focused. See if I can get it zoomed in a little bit more. There you go. All right. So now we're going to tell it to run. And there it is. Notice it's got the version 2 on it. And we've got the timer value, and I'm going to come over here. Let's see here. I got to use this hand over here to, that's going to make it. If I do that, you'll see, yes, we've lost our focus. But you can see that those values are changing. I'm going to put this down here, get it to, hold on, where I can use both hands. Okay, so I'm going to go down here. We've got a value change. I'm going to press button 1. And I'm going to change a different value and press button 2. Change a different value, press button 1. And you can see that that's all doing what it's supposed to do, even if it's not focusing very well. So, QED. Let's go back to the screen share. All right, so that's what I had for you today. Are there any questions? The next homework, yes. So I just posted the next homework this morning, which is due a week from Wednesday. The next homework is the same, only different. What I want you to do on the next homework is that instead of using individual tasks for each button, what I want you to do is that I want you to make the display task do all of the updates. So down here, this in this while loop, I want it to do all 3 line updates, but only when it's appropriate to change them. And I want you to use event flags to do that. So the concept here is that each button will post a different flag to the event flag, and you need to figure out a way that while you're waiting for that event flag, that you can still update the display every second. And you're going to be reading the A to D converter a little bit differently. I want that to be handled on a periodic interrupt. So that's what the next homework is going to be. Any other questions? Okay, well, I will see you guys on Wednesday. I don't know if I'll have your homework graded by the time that we get to class on Wednesday, but I'm pretty sure I'll have it all done by the end of the day on Wednesday of this week. Looking forward to seeing you all, and we'll talk to you later. Oh, and I'll get this posted, this video posted as soon as it finishes with Zoom's conversion process. All righty. Well, y'all have a great day.